This is a box plot that represents the heart rates of students during a math class. The box plot visually displays the intervals trapping the lowest 25% of scores, the second 25% or second quartile of scores, and the third and fourth quartile of scores as well. Remember, we tend to call each number in the data set a score. In this case, they can be called heart rates or scores. Consider the stem plot of the same data. We can easily find the median, and this value is represented by the horizontal segment within the box of the box plot. Being at the first quartile of 62 implies that a heart rate of 62 beats per minute traps approximately the lowest 25% of scores. Thus, the first quartile is also referred to as the lower quartile and is represented at the lowest edge of the box in the box plot. Finding where the upper quartile is at is finding the third quartile, a heart rate of 74 beats per minute. It isolates the upper 25% of scores and is represented at the upper edge of the box plot. By showing the location of the three key quartiles, lower quartile, median, and upper quartile, then we know that 25% of the scores are in the lower quartile, below the position of the lower quartile. 25% of the scores are in the second quartile, 25% are in the third quartile, and 25% in the upper quartile. Remember, if we are to state the value of the third quartile, the answer in this case is 74. If instead we say that a score is in the third quartile, then it implies that it is somewhere between 68 and 74. A box plot gives a quick, accurately scaled visual of the data using what's called the 5-number summary: the minimum score, the lower quartile, the median, the upper quartile, and the maximum score. Box plots can be oriented vertically or horizontally, and side-by-side box plots can be used to visually compare two different distributions of data. The second plot displays the heart rates after running 1 mile. As would be expected, we can see greater variance, a greater median, and larger quartiles for the heart rates following a run. A modified box plot displays outliers. Recall that the interquartile range is the width of the interval from Q1 to Q3. In this case, the IQR is 74 minus 62, or 12 beats per minute wide. An outlier is an extreme score in a data set that is at least 1.5 times the IQR above the third quartile, or 1.5 times the IQR below the first quartile. 1.5 times 12 is 18 beats per minute. To be an outlier, a score must be at least 18 units above the upper quartile of 74. Suppose we had a high heart rate at 98. This would be an outlier displayed in a modified box plot by a dot. The whisker would extend to the highest score that is not an outlier, and then a dot is placed where the outlier exists. A large set of data may have a few dots, one for each outlier. To check for outliers on the lower end, again multiply the IQR of 12 by 1.5, once again getting 18, and subtract this from the lower quartile of 62. This implies that any score below 44 would be an outlier. Now the lowest score in our data set is 54, thus we have no outliers on the low end.